The topic is sampling. Sampling. Sampling is the process of converting a continuous time signal into discrete time signal. Okay. Suppose a continuous time signal is represented by a xt, and its waveform is look like this. There is a sinusoidal waveform. Okay, here is t, continuous time t. Okay, now we have to sample this signal. Okay, sampling means taking sample of these signals at regular interval. Suppose here I am taking the one sample of this signal. Again, here I am taking one sample. Here is also here, here, here. Okay, so suppose this is instant 0th instant. In 0th instant we are taking a sample. At instant t1 we are taking one sample. At instant t2 taking one sample. In t3 this sample is taken. At t4 this sample is taken. At t5 this is at t6, this is at t7. Now this time duration is, that is t2 minus t1, that we are assuming it capital T. So this time duration will be same for all the samples. Okay, so here is also capital T, this gap is also capital T. Okay, so it the samples, if all the time durations are same, then we can say that the samples are taken at regular time interval. Okay. So after taking these samples, the signal looks like this. Okay, so the signal looks like this. Okay, this is the discrete time signal. Okay, and this signal is represented by xn. Instead of xt, it is represented by xn, and here is n. What is n? N is called discrete time index. Discrete time index, right? N is an integer value. Where t, small t is the continuous time, and here n is the discrete time. Okay, now the process of converting a continuous time signal, that is xt, into xn, discrete time signal xn, is called sampling. Now in mathematically we can convert a continuous time signal xt like this way: x nt equal to xt into at t equal to nt, right? Where t is called sampling interval or sampling period. So t is called sampling period, right? So sampling period is constant throughout the sampling process. Okay, so here capital T is constant, so it can be written as x of n. Okay, So this is the process of sampling. Now there is a problem when we are converting a continuous time signal into discrete time signal. Suppose a continuous time signal is a combination of 3 or 4 sinusoids or a number of sinusoids. Okay, in that case there are a different number of frequencies present in that signal. Okay, so in that case when we are sampling the signal, there is no problem. It can be sampled by a by assuming any sampling period. Okay, but when we want to recover the continuous time signal at the receiver section, then there will be some similarity between the samples within the signal. Suppose the signal is 3 sin 10t. The continuous time signal is a combination of this signal 20t and 5 sin 30t. Okay, so these are this is the combination of 3 signals here. They are in different frequencies, right? Now if I sample this signal, there is no problem. It can be sampled at any sampling period. Okay, but when we recover this continuous time signal in the receiver section, then the sample at this point, suppose at instant t1 matches the sample of this signal sin 20t at instant t1 also. Okay, and also at instant t1 the sample, another sample of sin 30t matches with this sample. Okay, this problem is called aliasing. This problem is called aliasing. Okay, so this is called aliasing effect, right? Now, so this is a big issue. This is a serious issue when we are recovering the signal in the receiver section. To avoid this problem, to avoid aliasing, we have to assume the sampling frequency, that is fs, or sampling rate fs, that must be greater than equal to 2 fm. Okay. Now what is fm? Fm is the maximum frequency present at the continuous time signal. Maximum frequency present at the continuous time signal. See, in this case this component has the maximum frequency. Okay, so what is the frequency? That is 30 by 2 pi. 30 by 2 pi, so 15 by pi is the frequency of this signal. So this signal must be sampled at 30 greater or equal to, greater than or equal to frequency greater or equal to 30 by pi, right? This signal must be sampled at a frequency greater than or equal to 30 by pi, right? So now this condition is called Nyquist sampling theorem. Okay, so this is Nyquist sampling theorem, and the frequency of 2 fm, the frequency 2 fm is called Nyquist sampling rate. Nyquist sampling rate. So this is the minimum sampling frequency which has to be used in case of sampling. Okay, whether the continuous time signal is a combination, when the continuous time signal is a combination of 2 or more sinusoids. Okay, so this is Nyquist sampling rate. Now what is sampling rate or sampling frequency? Sampling frequency is called sampling rate because we are sampling at t sampling interval. of time, t second sampling interval of time. Then what will be the rate of sampling? That is 1 by t. This is nothing but fs, sampling frequency. So this is called sampling frequency or sampling rate. Okay, so this sampling rate, the minimum sampling rate which has to be taken to sample a signal, that is fs equal to 2 fm. This rate is called Nyquist sampling rate. Okay, and fs must be greater than equal to 2 fm according to Nyquist sampling theorem. So this is called Nyquist sampling theorem. This is the mathematical version of Nyquist sampling theorem. Okay,